Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Let us analyze each step in the synthesis. Step A. The starting material is methyl 4-oxocyclohexane 1-carboxylate. The product has the ketone carbonyl converted to a 1,3-dioxolane cyclic acetyl, while the ester group CO2CH3 is retained. This is a ketone protection reaction. The standard reagent for forming a 1,3-dioxolane acetyl is ethylene glycol, HOCH2CH2O, with an acid catalyst. Option A proposes HOCH2CH2 to mercaptoethanol, which would form a mixed acetyl hemethioacetyl, not a 1,3-dioxolane, 2 oxygen atoms shown in the ring. Therefore, option A is incorrect. Step B. The ester group CO2CH3 is converted to CH2O, primary alcohol. This is a reduction of an ester to a primary alcohol. NaBH4 normally does not reduce esters under standard conditions. NaBH4 reduces ketones and aldehydes selectively. To reduce an ester to an alcohol, Lyell4, LAH, would be required. However, since the dioxolane acetyl is present and must be preserved, Lyell4 would be used carefully. NaBH4 cannot reduce esters, so option B is incorrect. Step C. The primary alcohol CH2O is oxidized to an aldehyde ChO. KMNO4 is a strong oxidizing agent that would overoxidize a primary alcohol to a carboxylic acid, not stop at the aldehyde stage. A milder oxidant such as PCC, pyridinium chlorochromate, or Swern oxidation would be needed to selectively oxidize a primary alcohol to an aldehyde. Therefore, option C is incorrect. Step D. The 1,3-dioxolane acetyl is hydrolyzed back to the ketone while the aldehyde ChO group is retained. Acetyl hydrolysis requires acidic aqueous conditions, i.e. H3O+, dilute acid water. This is the correct reagent for selective acetyl deprotection. H3O+ cleaves the acetyl to regenerate the ketone without affecting the aldehyde under mild conditions. Therefore, option D is correct. Options A, B, and C describe incorrect reagents for their respective steps, while option D correctly identifies H3O+ as the reagent for acetyl deprotection in step D. Therefore, the correct answer is D. Therefore, the correct answer is option D.